welcome to Main and 5WH channel with yet another very interesting topic about quantum computing, and we're going to discuss specifically on Qiskit today. So before we go there, I think one of the very important topic which has been the buzzword is about quantum computing. You can see that there are a lot of things which is happening in terms of linear algebra, Python, are not enough to get started on the Qiskit. So we will talk about how you can actually use Qiskit for building a quantum future. First of all, what is Qiskit? So let's jump in into the website to get a feel about this is how the qiskit.org looks like. It's an open source quantum development. That's what it talks. So it's an open source library. Basically, it facilitates use of quantum properties with Python. Okay. It has been designed and developed by IBM. Quantum in general, quantum community for people like anybody who wants to experiment. Okay. So you might have to know a little bit of Python, linear algebra, complex numbers, some theoretical fundamental concept of quantum computing so that you will be able to really use this particular Qiskit more effectively. Okay. So the question is why you need quantum computing over classic computing? Is it for circuits or something like it? No. Okay. It is actually, it must be the weird physics and mathematics driving the motivation. That could be partly true. Okay. Quantum computing is getting its bold feature from quantum physics, which takes it into an advanced level of performing computation. It can do what the classic computing cannot do, right? So can perform classically expensive computation in an efficient way. In fact, quantum supremacy is no more just a term given by John Preskill and was realized by Google's quantum research team in 2019. Okay, they actually proved that a problem that could take approximately 10,000 years to be solved by a most powerful supercomputer today was solved by a 53 qubit quantum computer in a feasible time. It proved that quantum computers have the capability of performing in a way that classic computers cannot think of. Okay, so that's very interesting for us to really look at why we are really need to look at. So here, if you really look at here, you have what does a Qiskit do? It accelerates the development of quantum application by providing complete set of tools needed for interacting with quantum systems and simulators, right? So you can have access to the circuits. You can access a rich set of well-studied circuits which can be used as a benchmarks. You can build blocks in more complex circuit or as a tool to explore quantum computing leverage. You also have hardware access, execute code on multiple quantum hardware architecture from superconducting qubits to trapped ions. And then you have algorithm, research and prototype, machine learning, optimization, chemistry application by building upon a library of quantum algorithm. Then you can do noise mitigation, study and reduce the impact of noise using. So you can see the full overview as you go to the website. When you want to get started with, you have two options. You can either start locally and use your favorite development environment, or you can get started online with IBM hosted Jupyter notebooks. So if you want to install Qiskit locally, you just need Python 3.6 plus, although it doesn't really recommend using a virtual environment with Anaconda. So you can easily install the stable installation, you select an OS, and you can select a terminal by telling pip install, and then you can start learning the free digital textbook to study the concept of Qiskit. There is a download available for you, and then you can jump onto the documentation. So it will get very detailed into, it's an open source framework for working with quantum computer at the level of circuits, pulses and algorithms. A central goal of Qiskit is to build a software stack that makes it easy for anyone to use quantum computer. However, Qiskit also aims to facilitate research on the most important open issue facing quantum computation today. It has four elements: QS Terra, which is composing quantum program at the level of circuits and pulses with the code foundation. You have Qiskit Air, which is basically accelerating development via simulators and noise model. There is Ignis, addressing noise and errors, and then you have Aqua, building algorithm and applications. So each one of them, if you click, you are going to get detailing about these functions if you want to really read it on what it will do, what is Terra doing. So I leave it that to our subsequent sessions. So this session was basically to just introduce you the QAS kit. So hope you go to the website, try to understand what it is, try to download, because this is the future and you really need to look at what kind of kits, development kits, what kind of frameworks, what kind of IDE is going to really make this simple for a developer and an architect. Thanks for watching.